So the Higgs idea, this whole business, has to do with the origin of mass. So first, what is mass? It's something we're all quite familiar with. You know, when you push on any object, be it a rock, a Mack truck, whatever, the resistance you feel when you push on the object is the mass of the object. Now, where does the mass of the object come from? Well, clearly, it's got to come from the constituents, the particles that make up the object. But then the next question is, where does their mass come from? Especially when we're talking about fundamental particles like electrons and quarks. Where does their heft, where does their mass come from? Here is the idea, according to this Higgs approach. Imagine that space itself is filled with a kind of invisible substance. It's called the Higgs field, but think of it sort of like a cosmic molasses. And then when particles like electrons, say quarks, if they're trying to move through space, they have to kind of push through this cosmic molasses, and they experience a resistance as they try to do so. It's sort of like if you throw a little pebble into a vat of molasses, you can see that the pebble is experiencing a resistance. The same would go for the particles. And that resistance, say, when you push on an electron from its interactions with that surrounding Higgs molasses, would be the mass of the electron. Now, that analogy is not perfect. It might lead you to think that an electron would always be brought to rest as it experiences some friction against the molasses as it's traveling through empty space. That's not correct. This drag force only manifests itself when the particle is trying to speed up or slow down, but it's not a bad way to think about how, according to Higgs, particles would be imbued with mass. Pushing through the ambient molasses is where the mass comes from. Well, this idea that space is filled with the Higgs field, this Higgs molasses, it's a kind of a wild idea. And when it was first put forward, frankly, most physicists didn't believe that this idea was correct. So how would you verify this idea through experiment? Well, here's one possibility, the one that has actually been done. Take particles, make them go around, say, the Large Hadron Collider near the speed of light and slam into each other. When they slam into each other, they kind of are banging into space. They're kind of slapping space. They're kind of spanking space. And when you spank space, if it really is filled with this molasses, then the molasses should kind of jiggle. And if you jiggle the molasses in the right way, you should be able to flick off a tiny speck of the Higgs field, and that tiny speck would be a Higgs particle. And that, indeed, is what we believe has happened at the Large Hadron Collider. Very hard to find these particles. Calculations show that roughly 1 in a trillion of these spankings of space, these collisions of particles, will actually flick off one of these Higgs particles. But now there's very strong evidence that the Higgs particle has been found, that this Higgs idea is right. The Higgs idea and its confirmation is really important for a number of reasons. Number one, we physicists aim to answer basic fundamental questions, and one of the most basic of all is, where do the elementary fundamental particles get their heft, get their mass? And this suggestion, which appears to be correct, is a vital step forward. A second reason why this idea and its confirmation is important is the Higgs particle is a new kind of matter, not just a new run-of-the-mill particle. You see, the particles that we know about, like electrons and neutrinos and quarks, they all spin around, sort of like a top, in a quantum mechanical way, but the point is they all spin around. The Higgs particle is the first species of elementary particles that doesn't spin at all, the first spinless species of particle. So it's like finding some alien new life form, but now in the kingdom of particles. So that's a very important step forward. The other thing that is worth emphasizing, especially when you come at physics as I do as a theorist, the idea of the Higgs field and the Higgs particle began as mathematical symbols in an equation in a paper. And then over the course of 40 years, through developing that idea, developing technology to test it, we've now shown that the mathematics led the way. It has shown us a deeper level of reality that we couldn't test when the ideas were first put on the table. And that transition from mathematical idea to a confirmed feature of reality, that's really what we theorists live for. So those are 3 reasons why we are so excited that this discovery has now been confirmed and rightly been awarded the Nobel Prize.